Welcome to the newest episode of my complete Factorio tutorial series. Today I'm going to tell you everything you need to know about trains. As you might have already noticed, this video is fairly long. If you only want to watch specific parts, you can find all the timestamps for the following topics in the video description. Building a basic rail line, signals, expanding to 2 trains, intersections, expanding to 2 lines, train network, train GUI, and last but not least, circuit network integration. Let's start building your first rail line. In this example, we will build a train which will bring ore from an iron mine back to your base, where it will then be smelted. The most important question you have to answer first is if you even need a train. For shorter distances, you can still get away with using belts. As a general rule of thumb, I would say you could build a train if the distance is higher than what you can see when you're fully zoomed out. So, if you go to the middle in between mine and smelter, and you can't see them when fully zoomed out, you can definitely build a train. If it's not even close, you should absolutely build one. Another important thing that trains excel at is the high throughput and the scalability. If you would have to lay multiple belts to transport your ore to your base, or you know that the throughput will still increase in the future, then it's also always a good idea to use trains. Now you know that you want to use trains, but how should a train look like? You have the option to build a train with locomotives on one side to get a single-headed train, or you can use locomotives on both sides for a double-headed train. Both types of trains have their advantages, but we will use double-headed trains in this tutorial because they are easier to use. See, single-headed trains need some extra rails to turn around, which is inconvenient for smaller rail networks. If you go big in the future with huge trains and stations, single-headed trains might have an advantage as they can be shorter. This leads us to the last consideration, train length. This one is very important and you should choose wisely, as it's the easiest to keep one train length across all your trains in the future. This will make it easier to build and reuse blueprints, thanks to uniformity. Shorter trains are easier to handle, while longer trains can transport more items at once, which will reduce congestion because you need fewer trains in total. I often use trains with 4 or 6 cargo wagons and 2 locomotives on either side. To get the number of locomotives you need for a double-headed train, you just divide the number of wagons by 2 or 3 and voila, you get the number of locomotives per side. For single-headed trains, you can just divide by 3 or even 4. The more locomotives you have, the quicker your train will accelerate, but it will also be longer. For this tutorial, I chose to use a 1-to-1 train, which means 2 cargo wagons and 1 locomotive on each side, just because it's nice and small. Now we have all the necessary information to build the very first train station. First you have to lay down some rails. To do that, you take your first rail into the hand and just place it down like any other building. Now you can lay more rails down like that, but it's smarter to click the green arrow to get into rail building mode. Now you see a green ghost, which will represent where the rail will be laid down once you click again. You can control this by just moving your mouse around. This mode allows you to lay as many rails as you have in your inventory. You leave this mode simply by putting the rail in your hand back into your inventory. To get back into it, you just have to hover over a rail while having a rail item in your hand. Then you can click on the arrow again. Now you should have a straight piece of rail that is long enough to hold your planned train length. Now you need to place down the train stop. Just take it into your hand and hover over the end of your rail piece where the train should come to a stop. You have to build it on the right side of the train, as you can also see by the yellow arrows. They represent from where a train will be able to pull into the station. It should end up looking something like this, and when it does, you just build the train stop. I would advise you to directly rename the train stop to something that makes sense. They have default names, but they can get messy really fast if you don't properly name them. To do that, you just have to click the train stop and click the rename button in the window that just opened. I named mine Base Iron Inn, but you can think of your own naming convention here. Just keep in mind that keeping it simple is always better. You can also use rich text here, as I showed in my tutorial number 6, to make your names even easier to read. As a next step, it's best to build a train so we can then build a station around it. For that, you start by taking your first locomotive into your hand and placing it down at the train stop. It should snap right in place when it's rotated the right way. The cargo wagons snap into place as well. Before you can place the last locomotive down, you need to rotate it first, so it faces the right way. In the end, the train should look something like this. When you hover over it, you should be able to see the green connections between all the carts of the train, indicating everything is connected together. Building the actual loading or unloading in this case is the next step. You can unload a cargo wagon just like a chest with some inserters. I would advise using fast inserters, or even better, stack inserters, so the train gets unloaded quickly. You can see exactly where the cargo wagons are by the white box around them. It would be possible to put all the items directly on a belt, but to increase unloading speed I always insert into some chests first. These chests also act as a buffer, which is helpful too. Wooden boxes are fine here as we don't want a crazy large buffer. I then use some fast inserters to put the items from the boxes onto some belts. The way I build a belt is helpful to get items on both sides of the output belt. Now we are pretty much done here. Congratulations! Just as a last little thing, we should also fuel the locomotives. They take the same fuel as furnaces, but higher quality fuel lets them accelerate faster. For now I will use coal as it's typically the easiest one to use. You can easily fuel the trains by inserting the coal into the locomotives like that. Now the red flashing fuel icons should also go away. After you finished building the first train station, you can directly build a second one, but I prefer to lay the connecting rail first. It really works the same way like when we built the rail for the station. Just try and plan out the path you will take first, so you don't end up in weird places where lakes or cliffs make it impossible to take the route that would theoretically be the shortest. It's also often a good idea to lay down some power poles as well if you need to. Now you have built the rail and you are probably already where the other station needs to be built. So just do that real quick, as you should be capable to do that on your own now. Just remember to name the train stop and to build the inserters the other way, so they insert the ore into the train instead of taking it out. Fueling the train here isn't necessary. You can pause the video now to build the stop yourself. Alright, this is what I ended up with, and you should get a similar result. In the next step we will set up the train to drive between both stations. We will do some troubleshooting later for the rare case that something doesn't work. To get the train to drive between both stations, you need to set up its schedule. This isn't that hard to do. To get started, you need to click on one of the locomotives of your train. Clicking on Add Station adds the first station. You can choose the right one from the list. I will choose Base Iron In. Now we need to add a wait condition by clicking on that button. This means once the wait condition is true, the train will leave the station and drive to the next one in the list. I will just use empty cargo inventory. Now the train will drive to the next station once its inventory is empty. To keep trains from waiting too long in a station, we can also use a timer. So let's add another condition. This time we will use time passed. Now you can see that they are connected with an OR. This means the train leaves once either one of the conditions is true. By clicking on it, we could set it to AND. With AND, the train would leave once both conditions are true, but we don't want that in this case. You can also change the time to something different, like a minute. For the purpose of this tutorial, I'm just going to choose 10 seconds. Now you can do the same thing for the other station. Just click on Add Station again and set up the conditions like you want them, this time using full cargo inventory. You can let the train drive by switching it from manual mode into automatic mode. Now the train should start driving. If not, or if there's any behavior that is weird, then just watch a little further as I'm now going to show you some troubleshooting steps. If your train doesn't leave the station and you see the text no path, then your train isn't able to find a path to the next train stop. This can have multiple reasons. If you have many train stops, you should make sure that the stops in the schedule are all correct. Maybe the track to the next stop isn't completed and there are small holes where there are no rails. If you're using a single-headed train, then you have to keep in mind that the train can't reverse and that you need to build a way for the train to turn around. Maybe your train is waiting forever, but there is no path text. This one is probably caused by a faulty wait condition. Just take a look at your wait conditions. If the condition is fulfilled, the bar is completely green. Depending on the condition, it might be stuck. This is because it's still not true. For example, if your condition is empty cargo and the bar doesn't move, then the cargo is still containing items. The output belt is probably backed up. Maybe you also forgot to change the train into automatic mode. In the case that the train's cargo doesn't change while it should, you have to check your inserters. Maybe they are pointed the wrong way. If your train just stops randomly and shows a red flashing icon, then it probably ran out of fuel. You probably have to check the fuel input in the station that supplies the fuel. Maybe it doesn't get any delivered. To get the train going again, you will have to insert some fuel yourself by opening the train's GUI and changing into the fuel tab. Here you can put some fuel into it. If all these steps weren't able to fix your problems, then I would advise either rewatching the video to see if you can spot a mistake yourself, or you can also just ask in the comment section of this video. The folks over at the Factorio subreddit, forum and Discord are also all very helpful if you post a good screenshot and an explanation of what behavior you expect and what really happens. Now let's talk about signals. They are very important for more complex train systems as they allow multiple trains to use the same rail. Just like in the real world, they are used to guide and control the flow of trains in your system. The basic rail signals work in a very simple way. All they do is splitting up your rails into blocks. Each block starts at a signal and ends at the next. You can see them visualized when you hold a signal in your hand. The different colored sections are the different blocks. Signals now indicate the state of the next block. If it's empty, it will turn green and thus allow a train to drive into the next block. But if there already is a train in the next block, it will turn red, which in return won't allow trains to pass into the next block. Chain rail signals now take this concept a little bit further, as they can also read the state of the next signal. If the next signal is red, it will also turn red, even if the next block is empty. If the next block is full, but the block after that is empty, it will still be red. In an intersection, you might also see a blue chain rail signal. This is due to the signal reading multiple signals that have different states. In this case, a train can magically know if it's allowed to pass based on which route it will take. Chain rail signals are also able to read the next chain rail signal, so you can get a long chain going if you need to. Both types of signals also control which way trains are allowed to drive, as trains can only take a route where signals are on their right side. If you want trains to be able to drive both ways, you will have to build signals on both sides of the track. But be careful that there aren't two trains that will end up being stuck. Chain rail signals will be your friend in this case. When building or hovering over a signal, you will see a convenient white indicator for where a train would stop and yellow arrows for which direction trains will be able to drive. Now that you know how signals work, we can upgrade our rail line to 2 trains. The first thing we have to do is build a way for the trains to pass each other. You can build a small thing in the middle of your track to allow this, but it's generally easier and better for future expanding to build everything out to 2 rails, one for each direction. For that, you just lay a second set of rails. I'm going to use a space of 3 rails in the middle, but you can go higher if you want to. Connecting them to your original rail is also easy, as you can just build an intersection in front of both stations with the rail building mode I showed earlier. Be careful here and double check if the rails are properly connected. You can do this by looking at the silver steel beams of the rail. They need to be connected. You can also just take a signal in your hand and hover over the section to see if the white indicators for where trains will come to a stop go both sides. Now look at your train. You will notice that it just takes the shorter rail, driving the wrong direction half of the time. To fix this, we will need to build some signals. The standard ones are fine here. First, you have to build the signals at the stations on both sides after you split into 2 rails, like shown in the video. This will not only prevent trains from driving into the station while the other train is already in it, but it will also set the correct driving directions. Now you should also build more signals like this across the track, to help increase throughput for when we upgrade this to hold even more trains. Now you're ready to build a second train. The best way is to stop the existing one in the station that doesn't supply fuel, so we can construct a new one in the station that does. To stop the train, you can just switch it back from automatic into manual mode. Now you can just construct a train like the first one. To make the setup of your schedule easier, we can just copy it from the first train. For this, you just perform a shift right click on the existing train to copy, and then you can just shift left click on a new train to paste. Now you can turn both trains back into automatic mode. You don't even need to stand close by the train to do this, as you can access the train's GUI through the train stop. Before we can start adding more train lines, we need to talk about building intersections. Reusing the same piece of rail is always great, but even if you decide to link everything together with separate tracks, you will get the problem that you want to cross 2 rails. That's why it's important to talk about intersections. You will need to build intersections when you want to build multiple train lines that reuse the same track or when you need to cross tracks. There are generally two types of intersections: the T-junction, which combines rails from three sides. Then there are also the four-way intersections, which are used when you need to cross two tracks. Your goal should always be to try avoiding the usage of four-way intersections whenever possible, as they are always less efficient because of their lower throughput. Building a simple T-junction is very easy. I always start like this with the rail that will go straight through. Now we can add the second rail with some spacing like this. Now it's time to connect everything together. Starting with the top rail is the easiest. Just make the connections like this. You might have to try multiple times to get the curve into the right place. Now we can connect the lower rail. For this we need to go a little bit straight, and then we build a connection into the other direction. You should end up with something like this. Just remember that the top connections aren't touching each other, while the lower ones are crossing. Once everything is looking right, we can add some signaling. I always start by placing all the chain rail signals. This step actually isn't very complicated. You just have to build one before and after every rail crossing. Now we can just replace the three outgoing chain signals with normal ones. That's already it. Now we can test everything. For this I'm using a cargo wagon. Placing one in the middle, for example, shouldn't block trains from going straight on a lower rail. The two upper connections should also be free. You can play a little bit more around with it and see how the signals react. Congratulations, you just built your first intersection. Four-way intersections are a lot more complicated if you want acceptable throughput. I'll link to some pictures and blueprints in the video description because we are just going to build a simple crossing today. You should avoid these at all costs as they are very inefficient, so please try to avoid their necessity when designing your rails. Alright, now let's build the crossing. Signaling works just like with the T-junction. One chain rail signal before and one after every crossing. One signal in the middle pieces is just fine here. Now you just have to change out the four outgoing chain rail signals with normal signals. That's already it. Now you can again test it out and see how signals react. You probably did everything correct when two oncoming trains don't block each other. That's already it with building basic intersections. You can use all your gained knowledge now to design decent intersections that perfectly fit your needs yourself. Alright, now it's time to get a second train line going. As an example for this tutorial, I'm going to use the nearby copper mine. The stations are built just like in the first example. Just keep in mind to supply one of them with fuel. I just copied the stations and they look like this. You should also be able to build as many trains as you need. I built 2. Connecting everything together with rails poses the last challenge for this. You will need intersections. My example track looks like this, but it will probably look different for you. In this case I just built a T-junction here and copied it down here. If you plan on running more trains in the future, then you should try to come up with a better station design that can easily handle multiple trains. In one of my Let's Play maps I built something like this, which is a way more elegant solution than what I built here. You should have the knowledge to design something nice yourself now. Just keep in mind that you can't do anything wrong, and if something doesn't work as expected, you can just rework it and that won't hurt you. Making errors and fixing them is what really teaches you all the concepts, so don't be afraid to do things wrong. Before you might want to build even more lines, I want to give you some general tips about building a full-blown train network yourself. Train networks always consist of main lines and your train stops. In my example, this is the main line and this is the train stop. Basically, the main line is the part of the network that is shared by all different train lines. You should try to norm the width of the main lines. The width is generally measured by how many rails fit in between both rails. I usually build them 3 wide because it allows for nice intersections. You could also go for a width of 2, but that makes it harder to build T-junctions. Going even lower doesn't make any sense, because then you won't be able to connect both rails like this. Going wider than 3 is possible, but I don't have the need for it. But you could use the space in the middle to build some solar panels and accumulators, for example. I always make myself a blueprint of one part of the main line. In the middle I build some power poles, and every second power pole I build some signals. This is easily tileable. Just try around yourself and find a design you like. Having the main line normed like this will make it a lot easier to reuse intersections and all other parts you will need. You could also use a bigger design with 2 rails in each direction. This will give you even more throughput, but it's generally not necessary, and it will make everything a lot more complicated. Now let's talk about some best practices. First, there is intersection spacing. You should always keep enough space between intersections so your longest train can still fit in between. This is important to keep your trains from doing stupid stuff and causing a deadlock where all trains can't drive anymore because they clogged everything up in a way that can't solve itself. Another important thing is proper signaling. Always use enough signals, even on the straight parts, to have throughput and to keep trains from stopping for no reason. You should also always try to keep trains from your main line whenever possible. Waiting trains on your main line is the worst case scenario here. You can circumvent this by building stackers on the input of your train stations. A stacker will store all waiting trains in a compact area. With version 0.17, there were a lot of improvements made to the train GUI that I'd like to talk about here real quick. You can access the GUI by either clicking directly on the train by standing close to it or through the map view. Alternatively, you can view all trains and access their GUIs through the little train icon by a minimap, or you can also click on a train stop to get a similar list, but only with the trains that have the stop in their schedule. The GUI window is broken up into 2 parts. The left side with the schedule and fuel view, and the map view on the right side. The schedule can be easily edited by dragging things around. You can also edit the color of the train here. The map view is where it gets really interesting though. Here you can see in red the path the train is going to take to the next train stop. When you hold down Ctrl, you can click on a rail to create a temporary stop there. The train will then try to drive there, wait for a few seconds, and then it will continue with its schedule as normal. This is extremely helpful, especially for personal trains. Holding Shift while clicking onto a train stop adds this train stop to the end of the train schedule. You can also zoom out and pan around to then directly click on other trains or stops here. This lets you control your trains very quickly. As a last point, let's talk a little bit about the circuit network. But what even is the circuit network? It lets you read out values from different buildings, then you can do something with them, and in the end you can control buildings based on these values. You can, for example, read out the number of items in your chests from a train stop. Then you can look at this value, and if it's too low it will trigger another signal, and then you could disable a train stop if that signal is active. You just connect things together with red or green wire. Some buildings like chests will directly add their number of items to the correct signals. These signals can be items, fluids, or virtual signals. Each signal can then have an associated number. There are some different combinators which can calculate, combine, or decide between 2 values and output a new value based on that. Typical buildings that can output values into the circuit network are chests, belts, inserters, tanks, accumulators, and many more. Some of these are also configurable. There are also lots of buildings which can act upon these signals, like inserters, belts, gates, rail signals. You can turn most things on or off based on circuit conditions. You can configure these circuit conditions to turn things on when a condition is true. For example, you can set it to turn a pump on when one signal is greater than, smaller than, equal, and so on, to a constant number or to another signal. If that condition isn't true, then the pump in this example would get turned off. Now let's look directly at trains. Here you can read out and set the state of train stops and signals. You can set the train stops to output the contents of a waiting train or the ID of oncoming trains. Train stops can be disabled based on a circuit condition, and they can pass any circuit network signals to the waiting train, which in return can use these signals as a wait condition. Rail signals can also send their current state to the circuit network, and normal signals can be set to turn red on a circuit condition. The circuit network is often used to make bigger train stops smarter. In large bases, you often need multiple train stops to load or unload trains quicker. This isn't a big problem, as you can have multiple train stops with the same name, and trains will choose the closest train stop. That means that trains will just go to the second stop if the first is already full. But trains will always go to the first one if possible, even if its buffer is full or empty. To work around this, we can simply connect all chests together and then to the train stop. Now this wire will carry the total amount of items in all chests. Now you can set the enabled condition of the train stop to the type of item you have in the chests to be greater than or smaller than a specific number you can set. You should set the number in a way that will allow the train to get completely unloaded or loaded without any waiting time. You can also do it a little bit more complicated. With some decider combinators, you could find out which individual train stop has the highest or lowest number of items. Now you can turn all signals red except the signal to the train stop with the most or fewest items. This will always guide trains to the train stop that's the emptiest or fullest. That were all the basics and some advanced things about trains. I hope you were able to follow along. If there are still questions, just ask in the comments and I will try to help you. If you want some more details on the individual topics, I can recommend you to take a look at my train tutorial playlist with multiple videos about all the topics I talked about in this video, just in more detail. These videos are made in the last Factorio version, 0.16, but except for some GUI changes, everything still works the same. If you learned something new, please leave a like and also subscribe so you don't miss any new videos and tutorials. Feedback is also always appreciated. Have a great time. See you all next time.